Hello everyone, welcome back to the Data Structures and Algorithms series. Today we will learn about time complexity, space complexity, and the big O notation. So what is time complexity? Time complexity measures how the time of an algorithm increases as the input size grows. So you guys can think of it of how long a program will take as the data gets bigger. What is space complexity? So space complexity, guys, it's similar to time complexity, except that it measures how much memory a data structure or algorithm will require or use. And what is big O notation? Big O notation is a mathematical way to describe the efficiency of an algorithm. It shows the worst case scenario, like the worst thing that could happen. It helps us compare algorithms. And here's a real world analogy, guys. Let's say we want to search for a particular name within a notebook. First of all, if the name is in alphabetical order or inside of the notebook, then we can literally flip the pages, which is known as logarithmic time. If it's random, you need to check every single page, which is known as linear time. Here's some common big O notations. So first of all, big O notation is represented with the capital O, and then in parentheses, the input size. Here's our first example of big commonly used big O notation. O of 1 means constant time. An example would be accessing an array or list by index. O of n, linear time, means looping through all array elements or list, or in a list, guys. O of log n, logarithmic time. One example would be the binary search algorithm. O of n to the power of 5, quadratic time. An example of this would be nested loops. And here's why all of this matters, guys. So number one, it tells us or shows us how our code will perform as our input size grows, or as our input size becomes huge or large. Number two, it helps us write faster, scalable programs. It's also used in coding interviews, tech jobs, and real-world apps. Here's a quick summary, guys. So time complexity, essentially it tells us how our code will perform as input grows, and big O notation is just the standard way to describe our time complexity and also our space complexity. So throughout the series, we'll be using the big O notation to analyze each data structure. So in the next video, guys, now that you understand what time complexity and space complexity and big O notation is, in the next video we'll learn about arrays. So don't forget to hit the like and subscribe button, and I'll see you guys in the next Data Structures and Algorithms video.